Hello everyone, John Regex here, and before we start today's video, I want to give a quick disclaimer as always. Despite my YouTube username being John Teacher, I am not a real teacher. I am rather a student of computer science willing to work through a couple of practice problems. And today's topic is regexes. Uh, in other words, it's regular expressions for those unfamiliar. And in today's video, we're going to be using the alphabet of binary strings, and that's sort of the universe we'll be existing in today. So without further ado, let's get started with the first problem. And I'm going to write the languages a little informal, so bear with me here. Yeah. So for the first problem, it's going to be the language that contains only ones and empty string. Okay, so I want you pause the video, take 10 seconds, think of a regex for the language that contains only ones and empty strings, which this is a D, by the way. Oh, in case that was unclear. Um, but yeah, all right. Now, another thing I feel like I should probably clarify as well. I will be using the star operator as we've always done in the past, similar with this language right here. And basically what that means, if I do a star, it would imply that the language is, oh God, that the language is empty string a, and so on and so forth. I'll be using plus to basically say, like, if I say 1 plus 0, then the set could be, then the set could be 0 comma 1. All right. Another way some people write it is union 1, which is a perfectly valid thing to say. Just keep that in mind. I will be using plus. And then yeah, parentheses, but we should be good with parentheses up until this point. Anyway, hope that was enough of an excuse to think about it. The language that contains only ones and empty string is 1 star. Now, as a side note, before the side note, the star operator, we generate the empty string, the 1, the 1, 1, the 1, 1, 1, dot, 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 and that gives us the language only ones and empty string. But as a side note, if I didn't say ones in the empty string, how would you do it? Well, all we'd have to do is attach the 1 to the front. And that would be sort of your bonus 1A problem. Because think about it, since this can produce empty string, if we sort of concatenate it with the 1 right here, then that solves our issue as such. All right, let's move on to the second problem. Will be the language that contains an even number of zeros. Language that contains an even number of zeros. And just so we don't get confused, that is from the last problem. So I want you pause the video, take 10 seconds, write something down for the language that contains an even number of zeros. So we want a language that contains an even number of zeros. So we could have 0 zeros or 0 zeros, we could have 2 zeros, we could have 4 zeros. Another thing to keep in mind is that it doesn't specify the number of ones. So we could have 0 zeros, we could have 2 zeros, we could have 4 zeros. Okay, so we're going to have to start thinking of cases like that. So a way that I'd recommend it is sort of our little think tank we're going to exist in is the parentheses. We're going to want an even number of zeros. So for every sort of section, let's call it like a section, a section, a section, and a section, I want you to only produce 2 zeros in each section. So we need a 0 and a 0. And in either the left or the right or the middle, don't forget the middle because we have a 1 right here in between these 2 zeros as a possible case. We just simply need any number of ones, whether it's no ones, a bunch of ones, or 1, 1. And that will solve the case where we could get two zeros for anything. And because it contains an even number of zeros, and that can imply none, the star right here is good without attaching a 0, 0 on the end or a 0, 0 in the front, which wouldn't be necessarily right anyway, but just to elaborate on that. And so this will be the language that contains an even number of zeros, and it's perfectly valid. But another thing that you could keep in mind is this one star right here is basically, it's kind of redundant. Let's what do I mean by redundant? Let's think of an example. 1 star, 0, 1 star, 0, 1 star, 1 star, 0, 1 star, 0, 1 star is 2 iterations of what we have right here. But notice how we have the double 1 star? Well, we don't really need that. And I actually claim that we could take this out of the parenthesis and move it to the front. Okay? So it would look more like this. 0, 1 star, 0, 1 star, star. And if we do the repetition pattern, this is our starting 1, and this is our repeating pattern. So yeah, just, something to keep in mind with redundancies. Like, you could clean it up on the exam, though. I'm sure your professor would be perfectly fine, unless they, for some reason, specify that they don't want any redundancies, that this would be a valid solution, and this would be an even more valid solution in my eyes. But yeah, let's continue with the third problem. The language of strings that end with 0, 1. Okay, 10 seconds. Think about it. All right, let's work through it. We want strings that end in 0, 1. So we have 0, 1, dot, dot, dot. Anything could be in the front. We just need to end it in 0, 1. Well, we're going to need a 0, 1. How do we describe anything? Well, think of it this way. Our alphabet contains zeros and ones, right? So we have two choices. Could be a 0, could be a 1. Ooh, choice. Remember that addition operator or union, if that's what you prefer. That's what I mean by choice. We have two choices. We could choose a 0 or a 1, but do we choose a 0 or 1 only one time? No. We could do it no times or an infinite number of times. That is the language for strings that end with 0, 1. Let's move on to the next problem. Okay, yeah, that's right. Just want to double check. All right. The language of strings that contain 101 as a substring. Okay. And it's going to be fairly similar to the ones that end with 01, but this time it's a substring. So what does that mean? 101, anything to the left or anything to the right? Well, we want to choose anything to the left, right? Well, we know how to do that. We have our 101, and we can choose anything to the right. Simple as that. Just a minor extension to what we had in problem 3. We're on fire. Problem 5. Let's keep going. So now I want you to think of the language for strings that contain exactly 1, 1. 1, 1. Okay. I don't know if there's a better way to describe this maybe, but 1, 1. Okay, what do I mean by 1, 1? Well, we have a 1. We could have anything to the left or anything to the right. Or can we have anything? Only zeros. Because we can have exactly 1, 1. Well, we don't have a choice, but we can have an infinite or nothing on either side. So instead of the 1 plus 0 star, well, we don't really need that. Instead, what we can do is we can only have zeros. That's our only choice. And then we have our 1 followed by a 0. And that is a regex that contains exactly 1, 1. Bang. Problem number 6. We are on a roll. I want you to think of a language that contains at least 2 zeros. 2 zeros. Well, contains at least 2 zeros, so let's think of some examples. 0, 1, 0, 0, 1, 0, 0. Infinite number of stuff afterwards. I don't know, 0, 0, 0. It's at least. What about 1, 0, 1, 1, 0? That's valid too. So we got stuff to the left, stuff to the right, stuff in the middle. Contains at least 2 zeros. We've seen this before. 1, or, no. I think I always started with 0. Let's try to keep it consistent. Sorry about that. Any choice to the left, we have a 0. Any choice in the middle, right? Middle, left, right. Are we seeing it? Dot, 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 0, dot, 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 0, dot, dot, dot. any choice in the middle, and any choice on the right. I don't know about you, but that looks like a completely valid solution to the language that contains at least two zeros. All right, let's move on to our final problem of the day. We're going to think of the language of strings that, oh, that looks like an A, sorry, don't begin with 00. All right, pause the video, think about it. This one's going to be a little harder. It is our last problem, so. All right, I hope you thought about it. This one's a little more challenging, and I want you to think about the cases of all the possible, like, kind of sort of substrings of our language leading up to the length 2. So for length equals 0, oh God. How could I describe length? Okay, I'll just write length. For length equals 0, okay, we could have the empty string. For length equals 1, we could have 0 or a 1. And for length equals, oh God, 2, we could have 0, 0, 0, 1, 1, 0, 0, 0. What do we not want? We want strings that don't begin with 0, 0. So this case we can't. And this case we have to be careful, right? Because 0 can technically evolve into like a 0, 1 or anything like that. Okay? So now that we know this, let's just simply try writing it out in our cases. So we could have this, or that, and maybe we have all the ors in between, which I didn't write ors here. I probably should have, but a lot of ors, a lot of ors. That's what I want you to think about. So we could have empty string as our case, right? Completely valid example. Okay, we could have, I'm going to skip the 0 for now because it's a particularly interesting case, but let's think about the 1. We could have 1, and then we could have anything after, right? Set, because it just can't begin with 0, 0. If we have a 1, that already breaks the case. But what does this also cover? This case right here is the 1, right? Well, anything after this would include this. So we've already taken care of this, and we've taken care of this. Sweet. I just realized I wrote a 0, 0. I apologize. That should be a 1, 1 as our last case. And the 1 right here also accounts for that case. Good. Only case we didn't account for is the 0, 1 right here. So we're going to add 0, 1, 1 plus 0 star plus. All right. We've accounted for everything except this 0 case right here. And we're going to have to think about this. So if we write plus 0 and then 1 plus 0 star, well, we're choosing 1 or 0, so that could, one of the outcomes for this would be dot, 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 0, 0, dot, dot, dot. You know what I mean? We don't want that, okay? So that's not a very good way to put it. I'm going to have to think here. And notice how the 0 here accounts for the case. Let's say if we started with 0 and then did a 1 and then did a 1 plus 0 star, well, that's already that and covering the 0 case. So the only case that we haven't accounted for, oh no, how do I, let's just undo. So the only case we haven't accounted for is just 0, because it just strings that don't begin with 0, 0. So just 0 should be fine. And if it does have, oh God. I hope it's easy to picture this. Sorry about that. If we just have a 0 right here, okay, the only other option we could have after the 0 is the 1. Then we could have a bunch of other stuff. But if we have 0 dot dot dot, could contain the 0, 0. So we have to be careful there. But 0 alone is a valid case. So this is the regex for strings that don't begin with 0, 0. Thanks for watching.